Welcome to this insightful session of Green Talk. We are thrilled to have you join us today as we delve into a crucial topic at the intersection of sustainability and engineering, integrating ASHRAE standard in green building certification, enhancing energy efficiency and sustainability. As the world moves toward more sustainable and energy efficient built environments, integrating globally recognized standards like those of ASHRAE plays a vital role in achieving high-performance green buildings. These standards provide essential guidelines for optimizing energy use, indoor air quality, and overall building sustainability, helping us to create spaces that are not only efficient but also healthier for occupants and the planet. Before we begin, a quick reminder to all participants. Please ensure your microphones remain muted during the session to avoid any disturbances. If you have any questions, feel free to drop them in the chat box and we will address them during the Q&A session. Now, without further ado, let me introduce our esteemed speaker for today. It is an honor to introduce our distinguished speaker, Engineer Chandana Dalugoda, a highly represented professional with an extensive career spanning 44 years in the heating, ventilation, air conditioning, and refrigeration fields. He is the managing partner and lead consultant of Chandana Dalugoda Consultants and serves as the director of the Green Building Council of Sri Lanka. His expertise and contributions have been widely recognized both locally and internationally. Engineer Chandana Dalugoda is a fellow of the Institution of Engineers Sri Lanka and a fellow of the American Society of Heating, Refrigerating and Air Conditioning Engineers USA. He is a member of the Chartered Institution of Building Services Engineers UK, a member of Engineering Council Sri Lanka, a chartered mechanical engineer, a certified building service engineer, a green accredited professional GBcsl, a distinguished lecturer of ASHRAE USA, and member of the Association of Consulting Engineers, SL. Engineer Dalugoda has been a visiting lecturer at the University of Moratuwa, the University of Vocational Technology, SLTC Research University, the Institute of Quantity Surveyors, the Institution of Engineers Sri Lanka, and the Green Building Council of Sri Lanka. With his wealth of knowledge, vast industry experience, and commitment to sustainable and innovative engineering solutions, we are privileged to have him with us today. Dear sir, we now invite you to take over this session and share your insights. Over to you.
Thank you, Rinusa. Good evening to you, everybody. It is nice to have with you here for this session. Today's session is integrating ASHRAE standards in green building certification, enhancing energy efficiency and sustainability. I'm going to talk to you on following areas today as the content. If I say introduction to ASHRAE standard and green building certifications, key ASHRAE standards relevant to green buildings, we'll discuss. Energy efficiency and sustainability enhancements through ASHRAE standards, case studies and real-world applications. Also challenges and future trends in green building and ASHRAE integration. Finally, conclusion and recommendations. Just suddenly you get into some problems. Yes. Right, that is got over. We'll come back. First thing we'll discuss about introduction to ASHRAE standards and green building certifications. Green building certification programs assess and recognize building design and constructed with sustainability, energy efficiency, and environmental responsibility in mind. Now, what we do, existing buildings will convert to a green building. New constructions, of course, we built from ground zero with sustainability, energy efficiency, and environmental responsibility in mind. So these certifications always help developers, owners, occupants ensure building minimize environmental impact on and operate very efficiently. Then what I want to show you is what is green design? This is a very common word, green. What is green? A green design is aware of and respects nature and the natural order of things. Now, it is a design that minimize negative human impacts on the natural surroundings, materials, resources, and processes. So that is green. Don't think a building with so many foliage, so many green plants, green color paints. No, it is not a green building. The other thing is sustainability is very stale subject now because everybody is talking. I wonder, sustainability word is really misused. For everything sustainability word is used. No wonder people might even use sustainability shooting, sustainability accidents. What is sustainability? This is the ASHRAE definition. Providing for the needs of the present without detracting from the ability to fulfill the needs of the future. So that has a long meaning. Providing for the needs of the present without detracting from the ability to fulfill the needs of future. So use sparingly, carefully, and save for future, something like that. So green buildings reduce solar heat gain into the building by their building envelope construction, which improves thermal comfort, reduce cooling load, reduce power consumption, of course, initial cost, but definitely improving the operating costs and reducing the carbon footprint. Also, another aspect is reducing CO2 content and improving occupant well-being. Let's see average savings of green buildings. Now, green building has savings like energy. We can see here, energy usage by 30 to 50%, carbon emission 35%, water usage 40%, solid waste 70%. So in a green building, performance over the full life cycles of the following areas: minimal consumption, minimal atmospheric emission, minimal discharge of harmful liquid effluents, minimal negative impacts on site, ecosystems, maximize quality of indoor environment. So the question is, why get green building certification? It is at a cost. Always, when we go for a green building, there is an incremental cost increase. So why? It reduces energy and water consumption, enhance indoor environmental quality for occupants, increase property values and marketability, support corporate sustainability goals, may qualify for tax incentives. Now, although we spend a little, we can surely reduce energy consumption by utilizing energy efficient equipment, materials, reduce water consumption using certain fittings, applying rainwater harvesting, use rainwater for gardening purposes, so forth. Now, enhancing indoor environmental quality. We discuss this in little detail later. Outdoor air is having pollutants. Same outdoor air filled up inside the buildings. When doors and windows are closed, same air is circulated over and over again. The impurities, the pollutant concentrations can go up. That will have a harmful effect for occupants. Fortunately, CO2 is the indicator. So by checking the CO2 content, we know the pollutant level increasements. So green buildings always provide acceptable indoor air quality, increase property value and marketability. When you have a green building, you can market it. Support corporate sustainability goals. Say some ownerships are collaborated with a corporate entities. So they have corporate sustainability goals. Now, for example, someone trying to, let's say a contractor, suggesting an air conditioner for a building, but that is owned by a corporate client. They might come and tell you, look, we can't install air conditioners unless you confirm your refrigerants are environmental friendly, zero ozone depletion, and low global warming potential. That kind of a situation. Qualify for tax incentives. Now that is coming up in Sri Lanka as well. If you are going for green building certification, especially Green Building Council Sri Lankan certifications, banks are now preparing to give you benefits. Importance of energy efficiency. Of course, it is known very well. Buildings are responsible for more than 35% of global primary energy use. 35% building uses. 60% of global electrical energy use by buildings. And nearly 40% of energy-related greenhouse gas emissions worldwide. All this is because of buildings. Eliminating greenhouse gas emissions from the built environment is essential to address climate change. We are discussing this a little later. Climate change, all this is what we are doing now is to prevent and reduce climate change. Popular green building certifications in the world. In world scenario, leading building certification, green building certification organization is LEED. That is Leadership in Energy and Environmental Design. That is from US and international. There's another popular one called BREEAM, that is Building Research Establishment Environmental Assessment Method from UK. And that is also international certification body, BREEAM. Other leading one is Green Star. That is Australia and New Zealand. Of course, you have another little certification bodies. This is the map, world map. Now you can see world map showing LEED certification, that is from US, Canada, Brazil, and also whole of India use LEED. Sri Lanka also use LEED, but we have our own standard Green Building Council, Sri Lanka. BREEAM is UK. Green Star, Australia, Tasmania, and New Zealand. Japan, they use CASB. So what is LEED certification? Certifying levels. You have certified level, silver level, gold, and platinum. You will have to earn points to achieve certified level. 49 points, up to 49 points, you can achieve certified status. Or silver rating, 50 to 59 points. Gold rating, 60 to 79 points. Platinum, 80 plus points. You will have to achieve. You will have to show. You will have to achieve. BREEAM from UK, they also have similar setup, but wording is different. Unclassified, pass, good, very good, excellent, and outstanding. So their marking system credits 30 and below unclassified. 30 to 45, good. 45 to 55 is rather 30 to 45 is pass. 45 to 55, good. 55 to 70 is very good. 70 to 85 is excellent. And above 85, it is outstanding. Green Star also have certain sections, 4-star, 5-star, and 6-star. 4-star, 15 points. 5-star, 35 points. You'll have to achieve 6-star, 70 points. Now you can see green building certification by Sri Lanka. So this green SL rating system, that is from Green Building Council of Sri Lanka. Green Building Council of Sri Lanka is affiliated to World Green Building Council. So they also offer similar system with, you can see, certified rating, silver rating, gold and platinum. Similar setup. Now, as example, rating system 2.1 for new buildings, there are 8 sectors under management. Project management, you can obtain maximum of 4 points. Sustainable sites, if you fulfill that, you get 25 points. Water efficiency, if you do all these measures, you get 14 points. Energy and atmosphere, you get 22 points. Materials, resources and waste management, 14 points. Environmental quality, 13 points. Innovation and design, 4 points. Social and cultural awareness, 4 points. Obviously, if you satisfy these things, your building carbon footprint is going down. We'll discuss those later. These are some of the certifications from Green Building Council Sri Lanka. First one is here, Green Rating System for New Constructions, 2.1, that's what I showed you. Green Rating System for Built Environment, another one. Sustainability Guidelines for MSMEs, that is a micro, small and medium scale enterprises. Also, they have labeling system for products. So this is all about green building certification system in the world. Now, we'll go through the standards. The standards that we follow to design green buildings. Key ASHRAE standards relevant to green building. What is ASHRAE? ASHRAE is American Society of Heating, Refrigerating and Air Conditioning Engineers, world biggest engineering institution, responsible for providing knowledge for engineers in air conditioning and refrigeration, heating, ventilation, those 4, and providing standards. There are about 100 standards, out of which few of these standards are used for green buildings. The main standard that we use in green buildings is the ASHRAE 90.1, energy standard for buildings except low-rise and residential buildings. Of course, we have 90.2 for residential buildings. ASHRAE 169, climate data for building design standards. We'll go through those things. 62.1 is ventilation and acceptable indoor air quality. 55, thermal environmental conditions for human occupants, that is comfort standard, 55. 52.2 is air cleaning, air filter standard. 189.1, that is the ASHRAE green building standard. That is the ASHRAE Green Building Standard. ASHRAE has a green building standard called Standard for the Design of High Performance Green Buildings. The other one is 135. It is BACnet protocol for data communication in buildings. All these things are used extensively in green building design. We'll take first one. That is 90.1 standard, energy efficiency. This standard covers building any LOP construction. (90.1) advise you how to construct, how to use materials to reduce energy. How? Now, in a tropical humid country, why tropical? Why tropical? What do you mean by tropical country? Tropical country. You know, Earth has a center latitude called equator. Then, on northern side, about 33 degrees, you have another latitude and another one below the equator. Those two latitudes where the sun stays over the globe. The countries who are situated in between these latitudes get sunlight every day. So that is called tropics. That's how it came, tropical climates. So tropical climates will have to reduce heat transfer into the building. So your structure should be built, reducing heat transfer into the building. All that guidance is given in 19.1. 90.1 gives building envelope materials, into the U factors, the insulation thicknesses, the K factor, thermal conduct, all that is given. We'll have to comply if you are doing the green building. Also, HVAC system, heating, ventilating, and air conditioning system. This standard gives the benchmark efficiency levels. You can't exceed. You'll have to select equipment based on those efficiencies. That means you can't buy equipment for price, for the make, for the country it is manufactured, or you are getting it free, or you are getting it at a discount. No. Efficiency has to be very, very high. All that is given in 90.1. Service water heating, of course, we are not doing that in tropical climates. Power. A lot of details are given with regard to power limitations. If you use a air handling unit, the motor power limitations are given. You can't have a higher fan motor for a given airflow. You'll have to comply. Lighting. We use lighting. Very sparingly we use lighting. No, we'll have to comply this standard. Lighting power densities. That is called lighting power densities. Watt per square meter for energy saving. Electric motor usage. All that is given the maximum efficiency levels. Next standard is ASHRAE 62.1 and 62.2. That is ventilation and indoor air quality. Now, you will hear this ventilation word in two occasions. In HVAC. One, ventilation for indoor air quality, ventilation for comfort. Now, in this 62.1, we are talking about indoor air quality, ventilation for indoor air quality. What is it? What is it? We need outdoor air into the building if occupants are in the zone. Places where no occupants, we don't need outdoor air. What purpose? To purge bad odor, impurities, pollutants, also supplying little bit of oxygen. So we'll have to calculate minimum ventilation rates. Yeah, this standard helps you to calculate minimum ventilation rates, and we'll have to comply. And this is being used in Sri Lanka. As a chartered engineer, you cannot sign for designs without minimum ventilation rates. For green buildings, outdoor air delivery monitoring is required. That means outdoor air CO2 levels has to be checked. Filtration and air cleaning equipment. Environmental tobacco smoke, of course, we don't use smoking areas. What this standard says, you can't have smoking. Of course, we are complying. But if any place that is required, it should be away from the occupied space. A certain distance are given. And air cleaning, something like entry mats, air filtration filters, all that is discussed in this standard. We are going to go through these things later. Thermal comfort, standard 55. Now, thermal comfort, of course, is a different subject. We don't have time to discuss all this. A thermal comfort governs by 6 factors. 6 factors, actually, 2 areas. One is a personal factors and physical factors. Personal factors, first one, clothing. Second is metabolic rates. Physical factors, temperature, radiant temperature, humidity, their speed. So comfort, that is thermal comfort, is depending on these 6 factors. How you are clothed, your metabolic rates, your activity, then any physical factors like temperature outside and the radiant temperature, humidity, moisture in the air, and of course air speed. All that is changes your thermal comfort. Now this standard gives you thermal comfort as PMV, predicted mean mode. And we can, by computerized a simulation program, we can check whether you're comfortable or not, given space. So in green buildings, we'll have to do this computer modeling program and see particular spaces, the occupants are comfortable or not. You have to prove PMV. Actually, that says PMV 0.5 to plus 0.5. These are range you'll have to be. And dissatisfaction 10% and below. Right. So I'm not going into details. So these are ASHRAE standard. Also, it include in this particular comfort area a exterior sound and interior sound. Although that is not in the standard, in green buildings we follow this acoustical control. Now interior sound, we use American National Standard S 12.8. Exterior sound, we are proud to say we are using Sri Lankan standard. We have a standard. Then comes, we are using ASHRAE Green Building Standard 189.1. You can see these for except low-rise residential buildings. Some of the things that we take it here. Climate zones. Why we need climate zones? Now, ASHRAE standard is written for every country on Earth. I mean, ASHRAE 90.1 energy standard. Now then, there's a problem how on Earth a building construction in America, building construction in Sri Lanka, building construction in Japan are 2 different things. How you can control this? Data. ASHRAE has done a remarkable thing. What they have done, they have categorized all the countries into climate zones. Climate zones. Not even countries. They are cities. Now this is climate standard. The same referring climate data for building design standards 169. Now India and Sri Lanka. Colored. What are these colors? Thermal zones are defined 0, 1, 2, 3, 4, 5 up to 8 thermal zones. Now 0 is extremely hot, 0. 1 is very hot. 2 hot, 3 warm, 4 mixed, 5 cool. they are meaning cool is for us. It is cold. Anyway, 6 is cold, 7 is very cold, 8 is subarctic and Arctic levels. That is completely frozen, entire island, entire country. So this is how they have given thermal zones. Now look at this. The latest standard, you have Sri Lanka. Most of the cities, I am really personally happy because right throughout we were fighting for this. I think I can remember way back about 20 years ago, suddenly Sri Lanka was dropped in the handbook. So I had to have a long fight. I submit a petition to ASHRAE. Look why Sri Lanka is dropped out, where Dalugoda Asia is a pinhead little country is there, but Sri Lanka is missing. That is due to some technical errors. They straight away corrected that and informed me, and we got the Katunayaka back again in the climate zones. Then recently we achieved all these WMO stations in Sri Lanka, but not in the ASHRAE. So we were writing to them, but then suddenly this standard, the latest standard 2021, has all the cities. Look at Anuradhapura. This is a WMO number. A climate zone is 0A, extremely hot. Batikilo, extremely hot. Colombo, 0A, extremely hot. Colombo Ratmalana, same. Gold, same. Hambantota, same. Then comes Kandy, 1A, very hot. I'm very, very sad. During my school days, outdoor temperature in Kandy was 24, 25. This would have been mixed or warm, but it has gone to a very hot. Then Katunayaka is 0A. Nuwara Eliya is the coldest, 3A. That is under warm. That is under warm anyway. So Putslam, Ratapura, Trincomalee, all 0A. So what about these climate zone numbers? Because 90.1, the data is based on this. Say if you want to use a building envelope data for green buildings for Sri Lanka, we refer climate zone 0 data that fits our Colombo area. If you are doing something in Noor area, we'll have to refer 0 climate zone 3A, something like that. Okay, we are discussing further later. So those are the ASHRAE standards used in green buildings. Energy efficiency and sustainability enhanced through the ASHRAE standards. We'll go into a little deep and see. Reducing carbon footprint and operational energy consumption. Reducing carbon footprint and reducing operational energy consumption. That is one goal of green buildings. How do we do that? We implement 90.1 to minimize energy performance in HVAC, lighting and building envelope materials. We are complying 90.1 in that area. Utilizing renewable energy sources such as solar, wind, and geothermal in a construction. Now, in Sri Lanka, we still don't do that, but back in UK, what they do, every building complex, they use these techniques very small way. Little bit of solar PV, a little bit of geothermal energy, little bit of wind power, small wind catcher, small wind turbine, very small wind turbine. So all collectively, you get renewable energy. I think Sri Lanka has to practice this in our green buildings. Reducing dependence on fossil fuels and lowering greenhouse gas emissions. That is our aim. We'll have to do that. Now, carbon calculations, usually it is done by lead associates or our Green Building Council associate professionals. They calculate a institutional carbon footprint, also embedded carbon footprint. We'll have to reduce embedded carbon footprint, embedded carbon as well as institutional carbon footprint. Now, in this case, I'm talking about institutional carbon footprint. How to calculate that? GHG emissions, that is greenhouse gas emissions equivalent to CO2. So you call CO2 equivalent is energy consumption multiplied by CO2 emission factor. So if you know the energy consumption, you multiply it by CO2 emission factor, it is given, then you can find how much of carbon dioxide metric tons is released to atmosphere. Green buildings, our target is to reduce that amount. Carbon footprint is your building annual carbon emissions is called carbon footprint. We all should have calculated carbon footprint of our house. How do you do that? You have your electricity bill. Every month you have kilowatt hours. Let's say 200 kilowatt hours. It varies. Assuming 200 into 12. Then you get the carbon footprint, rather kilowatt hours per annum. Multiplied by CO2 emission factor gives you carbon footprint. These are the GHG emission factors for natural gas, 1.82 10 to the power minus 4 metric tons of carbon dioxide equivalent per every kilowatt hour. These per every kilowatt hour. So natural gas, fuel oil 2.51, wood 3.47, propane gas 2.17, liquid propane 2, kerosene 2.48, fuel oil number 1 2.51, those things. Coal 3.56, that is the highest. No, there are some. Coal bituminous 3.21, coke 3.9, fuel oil 2.51, diesel 2.51. (2.51 into 10 to the minus 4 is the emission factor for diesel. But Sri Lanka have an energy mix, as you know, coal, diesel. Then what about a hydro electricity? Oh, that is green. We don't take that. So energy mix for Sri Lanka is 5.835 into 10 to the power minus 4. I will show you carbon footprint reduction example. Now you can see this building. This is Ceylan Towers, built in 1994. I was lucky. I designed this air conditioning system then, but I had a little research for green buildings here. You can see 2012 example, total kilowatt hours, that is annual consumption, 4.5 million kilowatt hours. 4.5 million kilowatt hours. When you multiply it by mix emission factor, you get the carbon footprint of this building in 2012. That is 2,645 metric tons of carbon dioxide equivalent. So the carbon footprint is 2,645. This is year 2012. Now, 2015. Now this building has screw chillers. Efficiency during 1994, 0.84 kilowatt per ton. 0.84 kilowatt per ton. 0.84 kilowatt per ton. But it was replaced with a very advanced chiller. Very advanced chiller. Kilowatt per ton, these is all full load, 0.5 kilowatt per ton, something like that. Just example. And their part load values are very much lower. So 2016, I analyze a total annual power consumption, 3.1, 3 million, 3.1 million. Or the carbon footprint is 1,820, 2,645. So there's a saving or carbon footprint reduction. That is greening. So this is a good example. Only complying with ASHRAE standards and improving the energy efficiency, you can reduce power consumption. You can reduce carbon emissions, reducing carbon footprint. So to reduce power and reduce carbon footprint, there is another way of doing. You can go for absorption chillers. Of course, absorption chillers are not efficient, whereas the chillers nowadays, these chillers are very efficient. COP is going up to 8 COP full load, whereas absorption chillers, the COP will be 1, very low efficient, but they are running without electricity. They are running without electricity. It is driven by heat. Now, this is called lithium bromide absorption cycle, where refrigerant is water, lithium bromide is absorbent. Run with waste heat, different waste heats. So that is a good option for green buildings. And also we can use environmentally friendly new refrigerants. I mean new refrigerants. Now what happened was, early day refrigerants, very early days refrigerants were ammonia, carbon dioxide, methyl chloride. In 1920s, scientists found very safe refrigerants. Very safe refrigerants. They call non-toxic, non-flammable, non-explosive, very safe refrigerants. Those were chlorofluorocarbon, like refrigerant R11, that is ASHRAE nomenclature, R11, trichloro, monofluoromethane. R12, CFC refrigerant, very good, very safe. Difluoromethane. And there's a HCFC refrigerant, hydrochlorofluorocarbon refrigerant, Colar 22, monochloro-difluoromethane. They were the leaders. But later, people found there's an ozone breach. We know ozone layer that prevents ultraviolet rays, bad rays hitting Earth. You know, that increase heat, not even that increase skin cancer, cataract in the eyes. So ozone breach, there's a small hole in the southern pole, where New Zealand, that side. Those CFC refrigerants were banned and disqualified and stopped manufacturing. We call phase out. Now, then they introduced HFC refrigerants, HFC, hydrofluorocarbon refrigerants, ozone depletion 0. So until today, we can't use refrigerant with ODP, higher ODP. ODP, ozone depletion potential, should be 0 always. But now, very lately, now we found, just because ozone depletion 0, but there's another problem that is called global warming. So the term is global warming potential, has to be low. Those common refrigerant global warming potential 1,000, 2,000, that kind of a thing. So the latest refrigerant R32, ODP 0, GWP 600. Then another very latest refrigerant found, R1234ZE, ODP 0, GWP 4. Those are the most suitable refrigerants for chillers. You should use this equipment. Another way of saving energy, ice thermal storage. Your chillers are running at night, we have 3 tariff, we have the lowest tariff. Night you produce ice. Daytime you melt ice. That is refrigeration for air conditioning. So that is a remarkable way of reducing carbon footprint. Now, chiller plant efficiency. This is how chiller plant efficiency has improved. Early days, it is 1990s, 1995, 1994, 0.8 was the limit. Now it is 0.5, 0.6. All this is full load kilowatt per ton. This is a page from 90.1, how to select a chiller, complying energy efficiency. These are minimum efficiency requirement. For instance, a water-cooled chiller, 150 tons and 300 tons. Full load efficiency, kilowatt per ton, 0.660, and part load efficiency, 0.50 kilowatt per ton. Path A means full load matrix. If chiller is running for a part load continuously, that application, so path B, then 0.68 kilowatt per ton and 0.44 integrated part load value. So we'll have to comply when you are selecting chillers. Not even chillers, single phase equipment like split units, that is given as EER, energy efficiency ratio. Now, all of you listening, if you are buying a split type residential air conditioner for your office, for your bedroom, don't stick to the price reduction. Don't stick to the name. Okay. Of course, you need the capacity, 12,000 BTU, 18,000 BTU, whatever. But selection procedure is energy efficiency ratio, cooling capacity divided by power input, EER. Now, EER should be 12. Quite unfortunately, the air conditioners coming to Sri Lanka is about 9 EER. 10 is the most. You can't use for green building, but you'll have to find, you can find more energy efficient. So this is the cap, 12 EER. Then three-phase equipment, 12 EER. VRF, 11.2. If you have a cooling tower, there's a energy requirement, performance requirement. Per 1 horsepower, it should deliver 40.2 GPM. That means every 40.2 GPM, 1 horsepower. 20 GPM, you can't have 1 horsepower. It should be above. That means 50 gallons per minute per 1 horsepower. Yes, that is very efficient. That's how we select cooling towers. Of course, cooling towers, if they are running 24 hours, you can have variable frequency drives for the fan. How it works? Controller is the cooling tower output some temperature. That drives the VFD. Air handling units, similar, fan power limitation. So there's a little equation. For constant volume, horsepower we can calculate for a given supply air flow. For example, 10,000 CFM, 10,000 CFM, 11 kilowatt. You can't have higher motor than that. The other thing is, the devices that we use in a green building, for refrigerator, for that matter, for photocopier, whatever, should be energy labeled. Energy labeled. High efficiency is A. Going down is very poor energy efficiency. Lighting. I told you at the beginning. Now, usually, this is the situation. See, normally in our office buildings, we have about 1.5 watts per square meter of lighting. That is the norm in Sri Lanka. But for a green building, you'll have to drop this to 0.82. These lighting power densities. For office, we'll have to comply. That is 90.1. Nanofilters, a latest situation. I was very fortunate enough. I went to Hong Kong to deliver my ASHRAE distinguished lecture in last year. I was taken to a nanofilter production facility. I saw in my eyes how it is done and how the MERV filter classification is given. With nanofiltration, pressure drops are very much less. Your HU fan motor horsepower tremendously going down. That is energy saving. Another way of cutting down, using DOAs, dedicated outdoor air systems. That is air handling unit. For places like large arenas, large banquet halls, what it does. The outdoor air requirement is supplied by the DOA unit. DOA unit has enthalpy wheels, 1 desiccant wheel and total energy wheel. Ultimately, what it does, if you had 100% fresh air coming like this, you would have had this much of enthalpy difference. But now it is reduced to this. You can understand. About 40% energy reduction. Another way of heat pipes for dehumidification with zero energy. Zero energy, mind you. What is dehumidification? See, in an air conditioning system, RH, comfort air conditioning systems, RH will have to keep it 60% and below. Usual norm is 50 to 60%. But in Sri Lanka, we can manage 55% to 60%. Sometimes, by nature of the system, or rather application, relative humidity increases. Our design is 60 and below, but your calculation, the simulation shows you are 65% RH. So you let it drop it down. Air conditioner cannot handle. You need reheating. That is a psychometric process, reheating. After cooling, you reheat. Then relative humidity drops. Now, reheating usually done by applying electric heaters. So massive electric demand for heating that is happening. While cooling, heating also required for dehumidification. But green buildings, that is out, completely out. You know what we do? We use heat pipe system. That means heat pipe system means this is return air hitting the cooling coil and supply air. Return air 24 degrees C, supply air 12 degrees C. Now, instead of hitting the cooling coil, return air now hits another coil where the 24 degrees C heat comes and drop in front of the cooling coil for reheat. See, this kind of a thing. First time in Sri Lanka, I installed one of the leading project. I'm going to show you that project, a Star Innovation Center. Very high certifications program called Germany Passive House certification. That is well above LEED. And I managed to drop the RH to 50 to 54% without single kilowatt used. That is called heat pipes. And the other thing is energy recovery. We'll have to use energy recovery ventilators to reduce the energy from outdoor air introduction. So outdoor air can be cooled by exhausting cold air from the room. For split units, we can use a recuperator like this, VRF and split units. We'll have to use this kind of an energy recovery ventilator. Extract 24 degrees C air, cools the incoming 32 degrees. Only sensible cooling. But larger cases, we can use energy recovery ventilators with enthalpy wheel. Advantage, it reduces sensible heat and it absorbs water vapor in the air coming from outdoor. So it removes water vapor too. Then another way of reducing energy, chill water reset by BMS. We raise the chill water temperature in part load conditions, especially part load, not loaded conditions, that directly reduces the building energy demand. Each degree of chill water reset reduces chiller energy comes by 1% to 1.5%. How do you do that? Chiller operates 7 degrees C. return 12 degrees C. Chiller out 7 degrees will raise 1 degree 8 and go to 9 degrees and watch. But this is done during part load. Fan cycling. Most of the fans are just working 8 to 5 or 24 hours, same speed, same airflow, which we don't need sometimes. So we can use fan cycling to reduce energy. Optimum start-stop. Now, all these things are coming from energy saving strategies using BMS. Optimum start-stop controls is very, very cleverly used in Sri Lanka, our installations. Especially the CEng bank that I showed you. That's why the energy saving that much. See, for 1 week, coming back for 1 week, Monday to Friday, you run the air conditioners 8 o'clock. Say this 8 a.m. I should not show that way. What I want to show you is a Monday to Friday, you have got Monday huge heat load. Tuesday slightly drop. Wednesday, and it is going down, building heat. But your air conditioner you run Monday 6 o'clock. Tuesday 6 o'clock. Then 7, 8, 8, 8. So 6 to 5, 6 to 5. You might think, oh my God, instead of running 8 to 5, you are running 6 in the morning to 5 in the evening. But thermal storage shows you week's energy demand is less than running 8 to 5. You don't believe? You'll have to do it. One of my installation just concluded in Sampath Bank head office, Union Place. We do this. Tremendous energy savings. Electrical demand limiting is another one. Electrical demand limiting, when the demand is going higher than the usual monthly level, this is tracked by the BMS, send a signal to all the DGCs where the set point of AHUs are raised. Normally 24 degrees C set point, raise instantly to 25 degrees C. So chiller will unload. It will go above the demand limit. So that's how you reduce energy. Indoor air quality, we introduce outdoor air. Now I told you there are pollutants. You can see pollutants. Carbon monoxide is a pollutant. Maximum threshold is 35 ppm. Lead, maximum 0.15 microgram per cubic meter. Nitrogen dioxide, 100 parts per billion. Ozone is bad. Maximum 0.07 ppm. Particulate matter, PM2.5, PM10. Particulate matter is particles suspended in the air, 2.5 micron size and 10 micron. So the maximum allowable limit is 12 microgram per cubic meter. So PM2.5, PM10, 150. Sulfur dioxide, 75 ppb. Now, for instance, particulate matter, if exceeds 12 and 150, they are PM 2.5, PM 10 respectively, you'll have to use air filters, special air filters. So you can see PM 10 non-attained areas, we'll have to use MERV 6 filter. G4 is European standard, MERV 6 is American standard. PM 2.5, you'll have to use MERV 11 filters. So ASHRAE 62.1 gives you how to calculate your outdoor air volume, outdoor air flow. You'll have to calculate breathing zone volume and multiplied by divide by zone effectiveness. Breathing zone calculation is very simple. You need to know how many people and rate per person, a figure. We can get it from a table. And you should know the area of the space multiplied by rate per area. These figures are given by table in the 62.1. I have given example, lecture room. People outdoor air rate is 3.8 liters per second per person. Let us multiply by number of people. Outdoor air rate, area rate, 0.3 liters per second per square meter multiplied by the area. So you get, and then divide by effectiveness. Of course, effectiveness is 1 for our systems, supply air and return air positively. So it is the normal calculation VBZ. How you do that? Number of people into a rate per person plus area into rate per area. You get the liters per second. That will have to provide. That's how we comply ASHRAE 62.1. Outdoor air delivery monitoring. We'll have to use special CO2 sensors, meters, and this is coupled with the BMS. If you don't have a BMS, this has to couple with a buzzer. If CO2 levels are going up, then we can open windows, doors for a short period to get the CO2 level down. Now, increase ventilation. There's another way of increasing well-being of occupants by increasing the ventilation air flow, but we calculated 62.1 method by 30%. That is, green buildings has to do that. But unfortunately, power consumption will go up because of the outdoor air quantity. Then we'll have to use energy recovery ventilators. So ASHRAE standard 90.1 give demand control ventilation. Another one, demand control ventilation. When a occupancy exceeding 40 people per 1,000 square feet or 40 people per 100 square feet, we'll have to use demand control. With a CO2 sensor, it works only for demand. Otherwise, no airflow supplied, less airflow supplied. Noise criterion standard, Sri Lankan standard for outdoor. It is National Environmental Regulations, number 1 of 1996. Low noise area, night time 45. We'll have to maintain our design. We'll have to address this. If it is municipal council area, 60 decibels, night 50. EP is in factory area 70, night 60. Silent zones, courts, hospitals, schools, 50 decibels, A scale, and nighttime 45. Now, this is the American standard for interior sound, noise criterion. For instance, office buildings, open plan of is 40 NC. That is the criterion. If you measure 45, that is decibel A weightage. We'll have to comply this. Then water conservation and renewable energy integration. For landscaping, we'll have to use rainwater, harvested water, or grey water. We'll have to use indoor water use reduction equipment like our water closets, taps, reduce water. Grey water recycling for gardening, for toilets, we can use. Thereby, we reduce the clean water usage. Cooling tower water efficiency. That is, you'll have to use a cooling tower with CTI certified, especially those cooling towers, drift loss, that is water carry over by air, drift loss. Water carry over by air, drift loss, has to be kept 0.005% and below. Then we minimize water usage, water saving by that way. Solar PV installations, definitely there is a common thing nowadays in houses. Wind energy utilization. Yeah, when we say wind energy, we remember large wind farms and wind tunnels. No, these smaller wind turbines are available. And geothermal energy. Now, this is every large a building complex. In England, they use geothermal as well. I was working in England, and one of my designs we used. So there are heat pumps, special heat pumps. During summer, you pump water to the ground through tubes. You get colder water for us to use. In winter, the other way, we get hot water. How? Not from the ground, you get cold water, but there's a heat pump. Heat pump. Heat pump, one side is refrigeration, the evaporator, one side is the condenser. During summer, the condenser water goes to earth. So we have cold side. We are feeding cold side. We are getting cold side. But in winter, the evaporator, that water going underneath earth. The condenser side, that is the heat pump, hot air for winter heating or hot water for winter heating. That is geothermal energy. Okay, we are coming to end of this session. Case studies. One of the case studies I can give you, IBC building in Sri Lanka, the first LEED Platinum certification. This is ICC building. ICC the owner. Green building consultant is engineer Mahendra Jailath, one of our green building directors. He did this green building consultants. Reduction in energy use, 45% reduction in water use, 30% reduction in carbon dioxide footprint. I'm very happy I was part of it for air conditioning design. We achieved tremendous goal. There is a first LEED Platinum building, office building in Sri Lanka. The other one is a very good milestone for Sri Lanka. World's #2. This milestone, passive house certification for Star Innovation Center, Katunayaka. I am very proud to be part of it. Of course, this is not a lead, these are Gbcsl, but this is some other certification that is called Passive House certification. Passive House Institute from Germany. Okay, challenges, barriers to implementation of our certification systems. The cost, little expensive. For instance, silver certification, 2% increment of cost increase, project cost increase. If we go for gold, 7 to 10% increase project cost. Platinum level will have to go 20% higher cost. But all of these life cycle costing is very much cheaper than a normal building. There's another problem. Ensuring code compliance may be challenging for certain types of building and the jurisdiction within the city or town. You may not be able to implement some technical challenges due to non-availability of equipment or suitable experienced manpower. That is also another hindrance sometime. Future updates. ASHRAE supports sustainable building practices, including building decarbonization to mitigate climate change. Now see, ASHRAE supports the development of decarbonization technologies such as next generation heat pumps, the adoption of stretch codes, building performance standards, standard 100, electric ready building requirements, building benchmarking and labeling requirements. So, to evaluate whether the building or group of building meet definition of net zero buildings, now ASHRAE has come up with a standard. These are the latest developments. ASHRAE standard 228. The other thing is role of smart building technology and automation. Future. Internet of Things. It is in Sri Lanka. We are using. Internet of Things offers a framework of flawless connectivity among sensors, systems, and devices through your hand phones over the web, enabling real-time data sharing and energy management process automation. That is Internet of Things. Artificial intelligence, AI. I'm afraid AI word is also now misused. Anyway, AI and machine language, both. While machine language use algorithms to let system learn from data, previous data, and grow over the time. AI describes the evolution of a human intelligence in robots. AI yet to come. That is helping. So conclusions. Enhancing sustainability and energy efficiency in green buildings utilizing ASHRAE standards is quite evident now. And the following is the summary. Reduction in energy usage and overall reduction of carbon footprint in buildings. Reducing environmental impact, reducing water usage, reducing global warming and complying with Paris Agreement to stay with 2 degrees C or below. Improving the well-being of occupants in building by improving indoor air quality. All that is the use in green buildings. So that's it. Hope you have got something out of it. If you have any questions, we can go through it now. Oh my God, there's a chat box comment from Chairman Green Building Council. Architect Jantapera, yes, sir. He says you should have mentioned Kandalama project, world first green hotel. As a matter of fact. As a matter of fact. Yes, we can share the presentation slides in PDF format. CB says point, Upul, thank you very much. It can't be 0.5 because diesel is 2.1 or something. So it is some mistaken there for the emission factor. There are some questions I'm going through. What are softwares that can use to simulate thermal comfort? Yes. I think everyone is still there. Hang on and listen. Please go to web. You type CBE thermal tool. CBE thermal tool. I think you can see now in my in the chat box. CBE thermal tool. So thermal comfort can be simulated using CBE thermal tool that is free in the web. Do Sri Lanka has any government regulations related to this energy reduction and greenhouse gas reduction? Of course, this way. There are guidelines and restrictions of usage of refrigerant, which are affecting climate. That is there. Thank you, Ranjan. And Kalyani Comprehensive, yeah, thank you very much. And Kalana from University of Moratuwa. Yes, Kalana. This is also, wow, thank you very much. And then, yes, that's it. Thank you very much. We'll conclude the session.
Thank you, Engineer Dalugoda. Thank you so much.
Thank you, sir. Thank you, Mr. Jantapera.